Hey folks, I've just had an interesting debate here on YouTube in the comment section on another video, another channel. And it's inspired me to make this video. Of course, it's regarding the subject what you see on the title about the rotation of the Earth. Now, before I continue, let me just tell you a bit about myself. One of my many hobbies is astronomy. I've been into astronomy since my early teens, probably before that. And I have my own telescope. I do, obviously, I stargaze, I observe the planets and the movements and stuff like that. So yes, this is a subject I'm quite keen on. Now, one of the consequences of being into something or having a hobby such as that is, what is basic knowledge to yourself? You make the assumption, the incorrect assumption, that that basic knowledge is basic knowledge to everybody else, and you don't realize there's a multitude of people that doesn't know much about the cosmos. There really is a lot. I mean, reality television, soap operas and stuff like that. That's sports. People tend to be more interested in stuff like that, but they don't really. Maybe some people see it as geeky. I don't know. But anyway, it's inspired me to make this video for the benefit of those who do not know much about astronomy, who has maybe a little bit of interest in it. Yeah. For most of you, you probably find it boring, so I could understand that. But anyway, for the benefit of those who want to know a bit more about astronomy. So, the rotation of the Earth. Now, this person I was having a debate with, they didn't understand observing the rotation of the Earth. So they said, well, now, how do I know the Earth is rotating? So, like I pointed out to them, I'm going to point out to you. There's a number of techniques, but I'm going to pick on the two techniques that it's more readily available. One is a technical way, and one's a very simple way. Both of them require a clear, starry night. Okay, let's start off with the technical method first. So you set up a camera, you set the shutter on very, very low speed, so it takes in as much light as possible. The result of that photograph would be stars that are blurry, but they'll have a what's that line? The best way I could describe it, imagine you're driving in a car doing 50 miles an hour down the road, and then if you look at the car that's parked to your left or right, you would see that flash line going away from the direction that you're traveling. So so the stars would have that blur line moving. Let me think. So if we're going this way. So the blur line would be in the opposite direction to what we're moving in. So we're rotating to the east, so the blur line would be heading towards the west. Okay, so that's the technical technique. Okay, so we go with, now we turn to the simple technique that costs nothing, free of charge. Right. So once again, you've got a clear, starry night. You choose a star or a star constellation over a chosen landmark. It could be a tree, it could be a building, church, a tall skyscraper, block of flats, house, a hill, any landmark you choose, right? So it's standing off. So let's for argument's sake, let's choose London as a location. Let's say it's, I don't know. Okay, let's say it's autumn and it's 7 o'clock in the evening, so it's quite dark, right? So you've chosen your star constellation or your star, you've chosen your landmark, and you've worked out where it's sitting. Go back an hour, 2 hours later, and you will notice that same star or star constellation has moved significantly to the right, because we are rotating to the left, we're rotating east, so the star constellation will be now sitting to your right or towards the west. The later in the evening you observe it, the further along it will move. Also, anyone who's took the time to set up a telescope to observe a star, you would know it's not as straightforward as just pointing up and just looking in. You have to damn well find the damn thing. Sometimes takes some time. So, and telescopes are very delicate to the touch. You can't even really touch it as such. Those who's familiar with telescopes would know what I'm talking about. So you may have your eyes on a planet or a star that's low to the horizon. By the time you finish fiddling around with your telescope, 5 minutes has gone by and you've looked up to locate that star and you've noticed, damn, it's freaking moved a little bit more to the right. I.e., that's the rotation of the Earth right there. This is something that's available for everybody to see. You don't need no big qualifications. It's not some kind of theory that acquires a lot of knowledge. You could just observe this for yourself with no equipment. Okay. Another thing this person said that I found quite surprising. I thought when they said this, I've read this before, and I've never really taken it serious. I thought it was maybe a form of mocking. I thought they were just sort of being silly, being childish. And what their person said is they don't feel the rotation of the Earth. And I thought, is this person mocking me? Is this person for real? And I realised it wasn't. It was deadly serious. Okay, so let me explain about feeling the rotation. I'll use an airplane, car, and a train. I'll start off with a train. So when you're on a train, on an express train, when it's moving at 100 miles an hour, okay, you notice you could walk up and down the carriage, no problem. What you're actually feeling, you're feeling the traction of the tracks below. And if the train slows down or accelerates, you're feeling the acceleration or the deceleration. If it then turns to the left or the right and it's moving fast, you may get a little bit of G-force, so you feel but that's what you're feeling. You're feeling traction. So if you're in an aeroplane, again, for those of you who've done air travel, you'll notice that when it reached cruising altitude, you could walk up and down the aisle, no problem. What you're actually feeling is air turbulence. So if it's going up and down, that's air turbulence. Of course, when it turns, you feel the G-force, but you're feeling it. So anything you're feeling is air turbulence. So take a car, aeroplane, or a train and put it in outer space, moving at constant speed, no traction, no air turbulence. You won't feel a thing. You wouldn't know that you're moving. To you, it'd be standing still, especially with the fact that the universe is extremely big. Stars are extremely far away. Objects are extremely far away from you. So as far as you're concerned, you're standing still. But you got to remember, those stars and those objects are also moving as well. So this notion that if we are moving at a certain speed, everything should be whizzing past, that would be true if you was close to the object and the object was stationary, then it'd be whizzing past. But the objects are also moving. Think of yourself on the motorway, as we say in the UK, motorway. In America, they say freeway. So imagine you're going down the freeway, everyone's moving the same direction as you, right? So nothing's whizzing past you. So, and even if someone is going in the opposite direction, if it was far, far away, it'd go past you very, very slowly. So I hope that I've made that kind of clear. I hope that makes sense to you, because I was quite surprised that a few people who've said this, they don't feel the rotation of the Earth. I thought, wow. Anyway, I'm not here to mock. I'm not being patronising. Please don't take it the wrong way. I'm just surprised that this wasn't general knowledge. So probably the education system needs reviewing or something. I don't know. But anyway, I'll probably do another video on the subject of astronomy for those who are interested. And for those who are interested, I hope I've enlightened you, and I hope it's been of some help. And thank you for taking the time to watch my video, and thank you very much. Okay. Whatever you're doing, have a good evening. Okay, bye.